Hello, hi everybody. Let's run a little experiment. We're going to collect some data from this free fall apparatus, and we're going to analyze that data on Excel. So what we've got here is a free fall apparatus. There's this plumb bob here at the top. This is just a plastic cylinder, right? But you can see this metallic ring around the outside of the cylinder. And what we do is we hang that metallic, or that plastic cylinder, we hang the plumb bob from an electromagnet here. And then when we release the electromagnet, it's going to fall. Now, at the same time, we're going to generate sparks, spark generator here. And what happens is electricity goes from this front wire through the ring, through this piece of wax paper, and when it does that, it'll melt some of the wax and leave a mark, to a wire that's behind that wax paper. And so what happens is we're able to see where the plumb bob is every 60th of a second. We're going to measure that data, and we're going to analyze it. All right, so the experiment's pretty straightforward. Go ahead and start the spark generator, and then release the plumb bob. Okay, and we'll take a look at the data here in just a minute. Okay, I just want to show a couple of things from the experiment once again, just so you see up close what's going on. So here's the plumb bob up in here. I get to use my drawing tool, that's always exciting. Here's the metallic ring. And then here's the front wire right here. Then there's this piece of tape, that's wax papered tape. And then what I've done in this image is I've moved the wax paper over the side so that you can see the wire in the back. And so there's a wire, there's the metal ring, and then there's another wire here at the front. And what that does is it's all close enough that allows electricity to pass through from the front wire, through the ring, through the paper, which is, I've moved it here, but it would be there normally, to this back wire. And so that melts the paper so you can see what the markings are. And so now in this image, you can see some of the wax paper, right? And there's a mark here, and here, and here, and here, and here. And then I'd ignore this first mark. If you can see how big that hole is, that's because, keep in mind, I'm pushing that button before I release the plumb bob, and so it's burning a pretty large hole in this wax paper before it even goes down. And that's okay. That means it doesn't start from rest. If I count that dot right there, let me just circle that dot. Actually, let me erase all this other stuff. So that dot will be my 0 time. So it's moving. It's not starting from rest, because I don't know with that dot above it, I don't know, when that dot clicked. Did it click the exact same time that the thing started falling? I doubt it. So I don't use that one. I use that first one. So there's dot 0, if you will, dot 1, 2, 3, 4, etc. And then here you can see more dots. And if you take a look, notice how the distance between these two dots is smaller than the distance between these two dots. Right, so they're getting farther apart. And I'm not going to get into the physics on that, but that's because it's accelerating. It's getting faster as time goes on. And each set of dots is 1/60th of a second apart. And so this is a little farther down on the tape. You can see the dots are farther apart again. And then this is towards the bottom. You can see the dots are fairly far apart. All right, early on we looked at this piece of tape and we took some measurements. And we looked a little bit at the dots that are on here. We saw how this tape was created. So we want to do a little bit of work with designation as far as calculations are going to concern. By designation, I mean subscripting. So I'll get into that in more detail here. Let's take a look. All right, so if I look at this up close, we have some dots on here. Remember, this was this top dot, and we didn't count that one, right? So we said, hey, let's not worry about that, because I'm not sure. First off, it's way too big. So even if I take a measurement, it's not very accurate because it's such a big dot. But I'm also not 100% sure when it ticked before I released it. Did it tick at the very same time it was released, a little bit before? I don't know. So we went with this one. This was our 0 mark, okay? My 0th dot. I don't want to call it the first dot. I'm going to call it the 0th dot because that's where 0 is at. And so when I subscript that, I subscript it with a 0. So that's x0. And then my first dot at 0.4 centimeters is going to be x1. And then at 1.3 centimeters, I'm going to have x2. And then I can continue down to x3 and x4. And then I go down the page and I've got more dots. And so here's a couple more dots. I don't know where these are on the paper. You know, is it the 5th one, 7th one? I don't know. So I'm going to designate, I'm going to actually go to the middle one. I'm going to designate the middle one here as x sub k. Sometimes we use x sub I, but in this case I'm going to use x sub k. I just like it better, so just a Paul thing. Okay, so notice the dot before, this is dot x3, so before that was x3 minus 1. 3 minus 1 is 2. And so this dot over here is going to be x sub k minus 1. And this dot down here is going to be x sub k plus 1. And what we want to do is we want to calculate the velocities. We've measured their positions. So this is going to have some value, this is going to have some value, this is going to have some value, right? And so in this case, x1 is at 0.4 centimeters, x2 is at 1.3 centimeters, x3 is at 2.3 centimeters. So this one has a measurement of x sub k minus 1, this one has x sub k, and this is x sub k plus 1. So how do I find the velocity? Well, you know that velocity is distance over time, right? Distance over time. But what do I do in this scenario? Well, I could find the distance from here to here, and then I would divide by the time increment. Remember, the time increments are 1/60th of a second, right? So that's each of the individual time increments. So if I take this distance, whatever it is, and I divide by 1/60th, that's a speed. Is it the speed here? No. Is it the speed here? No. It's the speed somewhere in between. Where in between, I'm not exactly sure. When in between is exactly the halfway time. Now, the halfway time, this is a distance position here, right? That's not the time. But I can take advantage of that same idea, and I can say, hey, the velocity right here at xk, that velocity is half time between this dot and this dot. It's half time between x sub k plus 1 and x sub k minus 1. So if I want to know the velocity at this time, I'm going to measure from here to here, and I'm going to divide by the time interval. So what's the distance from here to here? Well, that distance is x sub k plus 1 minus x sub k minus 1. Right? This is going to be at some distance, this is going to be at a different distance, smaller. So for example, if I wanted to know the velocity at x3, I would take 3.5 centimeters. So let me label this V3. This is going to equal x4 minus x2 over the time interval. Now keep in mind the time interval here is 1/60th, but then there's another 1/60th, right? So that's 2/60ths of a second. And this will be true throughout the entire spreadsheet if I'm going from the previous dot to the later dot. So in this case, that would be 3.5 centimeters minus 1.3 centimeters all over 2/60ths of a second. And so in a similar fashion, arbitrarily it'll be x sub k plus 1, whatever this length measurement is. Remember, this is the length from 0. It's the length from 0. So x sub k plus 1 minus x sub k minus 1, and then I divide by the time interval. I'm just going to put delta t. Delta is a change in time, right? So delta is a symbol that we use in mathematics. You may or may not have seen this already. Indicates change, so the change in time. In this case, it'll be 2/60ths of a second. All right, and that's going to equal the velocity here. So that's going to equal v sub k. That's the velocity at this point. That's going to be the speed, velocity in this case, because we know it's going down at this point. And that's how we measure the velocity. And that's what we're going to do on the spreadsheet. So let's take a look at how all that takes place.